Today we will learn about row echelon form of a matrix. If a matrix is in a row echelon form, then it follows two key rules. Let's write those rules and then see why this matrix is in row echelon form. So rule number 1, that all rows with all zeros must be at the end of the matrix. That rows with all zeros must be at the end. And you can see that in this matrix, which I written as example, there is one row which has all zeros, and that row is at the end of the matrix. If that row was maybe the second row, then this matrix would not be in the row echelon form. The second rule of row echelon form is regarding pivot. So before writing that rule, let's first understand what is pivot. Pivot is also known as leading coefficient. So in a row, a first non-zero entry from the left hand side is called pivot. So if for this row, the first non-zero entry from the left hand side is 1, so 1 is pivot. And for this row, first non-zero entry from the left hand side is 3, so 3 is pivot. And for this row, first non-zero entry is 1, so 1 is pivot. And there is no pivot in this row because all the entries are 0. So second rule says that pivot of a row must be to the right of the pivot of the previous row. So that means that if this pivot 3 is on the right of 1, then it is in row echelon form. If 1 is not here, and if I write maybe a non-zero entry is here, that means that entry will be pivot, and then the pivot will not be on the right of 3, and it will no more be in row echelon form. But in this case, because the pivot 1 is on the right side of 3, that's why it is in row echelon form. So now let's write that rule out. So rule number 2, which is regarding pivot, is that pivot of a row must be on the right hand side of the pivot of previous row. To make this concept more clear, I will write 3-4 examples, and then we will find that what are the pivots and if those matrices are in row echelon form or not. So I have written 3 different examples of matrices, and we have to find out if these matrices are in row echelon form or not. We have to identify pivots, and we have to see if these rules are fulfilled or not. So let's start. So in example number 1, first of all we have to mark all the pivots with a circle. So what's the pivot of this line?
1.
This one, right?
First one, yeah.
And this line?
There is no pivot.
There is no pivot here?
Because under every pivot, isn't it supposed to be 0?
Pivot?
I don't get
There
it.
So the
pivot, row echelon form doesn't matter. Pivot is first non-zero.
3. I'm 1.
One.
1, 1, 1, 1.
So this is the 1 is pivot.
Yeah.
And then what's the pivot on this line?
Okay, cool. That's it.
What's the pivot in this line?
1.
1. Okay, so now we have identified all the pivots, and now we have to see if these 2 rules fulfill. So rule number 1, it says that all rows with all zeros must be at the end. Is it rule fulfills?
Yes, because there's
So-
zeros at the end.
One row which has all zeros is at the end. Rule number 2 says that pivot must be always on the right side of the pivot from the previous row. So this pivot is no row above, so it can be anywhere.
Yeah.
This is on the right side of this one.
Yes.
Yes, so that means here the rule fulfills, here the rule fulfills. Now this one,
No,
So it's not in row echelon form. Now second one. In the second one is, once again we have to identify all the pivots which are the leading non-zero elements, which in this case is what?
1.
1. This case we don't have
There is
any
no
pivot. In this case,
1 again, and then 1 again.
and now we have to see if any of those rules are violated.
First one is
The
not.
first rule is violated because a row with all zeros is not at the end of the matrix, instead it is in the middle of the matrix. So obviously this rule is violated. And but if we ignore this one, if we ignore this row, otherwise if this matrix is an echelon form, so all the pivots must be on the right hand side of the previous pivot. You can say that this one is the right hand side of this one is the right hand side of this one. So we have only violated the rule number 1, but rule number 2 is not violated. If this row would have been at the end of this matrix, then we have a matrix in the row echelon form. So now let's see the last matrix. In this matrix, what's again? Identify pivots. We have pivot here, we have pivot here,
And no pivot on the 2 lines.
and there are no pivots here. And this pivot is on the right hand side of this pivot.
Yes.
So that means, and first pivot position doesn't matter because it's the first pivot. So rule is followed here, and rule is also followed here and here because these are rows with all zeros and they are at the end. So this matrix is in row echelon form,
Yes.
right? These two matrices are not in row echelon form, but this matrix is in row echelon form. So now we will talk about another similar form which is called reduced row echelon form. So we know the row echelon form, but which is known as REF. Now we want to talk about reduced row echelon form, which is a double REF. So let's talk about reduced row echelon form, which is known as in reduced row echelon form, is also in row echelon form. That means these two rules are still fulfilled, but there are some other rules. So you can say the rule number 3 is that pivot must be equals to 1. So rule number 3 is, in that case, that pivot
Must be 1.
must be 1. And the rule number 4 is, that all the entries above and below pivot must be equals to 0. That means in a row, in a column where this pivot is, all the entries above and below must be equals to 0. So all elements of a column, obviously except pivot
Must be 0.
must be 0. So you can see that here this is in reduced row echelon form because we have pivot here, here and here, and we have followed all of those 4 rules because pivot is equals to 1.
Wasn't the first two that you should all zeros at the bottom row?
Yeah, so we don't have to have all zeros rows. If there is a row with all zeros, then that row must be at the bottom. In this case, there is no row with all zeros,
Okay.
right? So rule number 1 says that if there is a row with all zeros, that row must be at the bottom. But in this case, we know row with all zeros. So rule number 1 is also fulfilled. Rule number 2 is fulfilled because all the pivots are on the right of the previous pivot, right? Rule number 3 is fulfilled because pivot must be equals to 1. And rule number 4 is fulfilled because all the entries above and below pivot must be equals to 0, right? So this is a reduced row echelon form. Usually, when we program in computer, we write program for reduced row echelon form. But when we are solving by hand, usually we only use row echelon form instead of reduced row echelon form. So in the next video, we will see that what are the application of this row echelon form and why we have learned row echelon form, and what are the applications of elementary row operations.